back to another Matt Explained Science video lesson, and today we will be looking at the concepts of accuracy and precision. Accuracy and precision are two terms that are used often interchangeably in English, but there exists a subtle difference, and in the analysis of scientific data it is important to use each term correctly. Accuracy describes how close a measurement is to the true value, whereas precision describes how closely two or more measurements agree with one another. Let's look at a classical example of throwing darts to help us visualize these two concepts. So, in a game of darts, a player receives 3 throws each turn. If we're trying to get as close as possible to the bullseye in the center, then we can see that in this instance the throw was both precise and accurate. Precise because the throws were all close to one another, and accurate because they were very close to the bullseye. In the second turn, the 3 darts landed far from the bullseye, so they were inaccurate, but they all landed close to one another, so we can say they were precise. In the final turn, the darts thrown were neither accurate nor precise. Inaccurate because they were far from the center, and imprecise because each dart landed far apart from one another. So how does this relate to science and the laboratory? Well, it's very important to repeat measurements and to check the precision and accuracy of the equipment we are using. In the following example, we can see that 3 chemistry students were asked to measure the pH of an unknown solution 3 times each. We need to make some observations about the accuracy and precision of their measurements. Our 3 students, Aaron, Becky and Carlos, each took the pH value of this yellow solution 3 times. Aaron's results were the following: 6.39, 6.50 and 6.44, giving him an average of 6.44. Becky's results were 6.19, 6.88 and 6.64, with an average of 6.47. And finally Carlos with 7.22, 7.19 and 7.25, with an average of 7.22. It is important to note that because pH is measured on a logarithmic scale, the averages cannot be taken directly from the pH obtained, but rather by converting the values back to their corresponding hydrogen ion concentrations and taking the average from there. With the average hydrogen ion concentration obtained, this value can be converted back to a pH value. But don't worry too much about pH conversions just now, as we're more interested in the accuracy and precision of the measurements. Without knowing the true pH value of the solution, we could see that the pH values measured by Carlos were a lot higher than the other 2, suggesting an accuracy problem, whereas the results for Becky are quite dispersed, suggesting precision issues. But if we know the true pH value of the solution is 6.43, we could confirm that Aaron's results were both precise and accurate, indicating that his pH meter is in good working order. Becky's results were accurate but not precise, indicating perhaps that her pH meter is calibrated correctly, but the measuring electrode could be dirty, for example. And Carlos's results were precise but inaccurate. Inaccurate but precise measurements usually indicates that the pH meter is calibrating with the correct pH buffers. Okay, that was just a quick video about accuracy and precision. Thanks again for watching, and stay tuned for more content. Please like and subscribe. Thank you very much.